Guys, Miss Dixon here. So we are talking about polyatomic ions right now. Um, if you have your orange book, we are on page 144 looking at our list of polyatomics. Okay. You are going to want to mark up this list. You're going to want to keep it handy. If we were in in-person school, we would actually have you memorize these. So like flashcards and um, quizzes to make sure that you had them memorized. Because you're at home, we can't really tell if you have them memorized or if you just have the list out. So if you're planning on taking an advanced level chemistry class down the road, I would definitely work on memorizing these. If this is maybe the end of the road for you in chemistry and you're just working to get through this class, if you've got this list out for right now, you're probably good to go. You'll notice that I highlighted some of them in blue. I've got that picture for you again on the next slide. So if you don't grab it during the video, you can always go to the next slide and see exactly which ones I have highlighted so that you know which ones that you are going to see pop up over and over again in class. Okay, so what is a polyatomic ion? Polyatomic ions are groups of atoms that are always going to be bonded together into these specific partnerships, and they're going to be treated like a single atom. So what I mean by that, if we look at this one right here, this is a hydroxide, okay? It doesn't mean that oxygen can only ever exist bonded to a hydrogen. What it does mean, though, is when we have these two things bonded together, they are going to function like one single atom, even though there's really two of them, okay? So let me show you an example. So if I look at sulfate here, sulfate is one of the polyatomics we're going to see a lot during the year. Sulfate is SO4 with a -2 charge. So what does that mean? It means I've got a sulfur atom with 4 oxygen atoms bonded to it. And this whole thing together has a -2 or a 2- charge here. Okay, so that's going to be important. That should look similar to those oxidation numbers that you saw when you were looking at formula writing earlier. We're going to come back to those. We're going to use this oxidation number to write formulas with polyatomics in the next part of this lesson. Okay, so the idea here is just that these are groups of atoms that are going to exist together like this, and the whole group of atoms has one oxidation number or one charge that we're then going to use to bond it to something else in an ionic bond and to form a compound. So one more example for you here. We talked about hydroxide. Hydroxide is an oxygen atom bonded to a hydrogen atom, and those two together have a negative or a -1 charge that would then allow them to bond as an anion with something else that has a positive charge.